it visible?
No, ma'am.
No?
No.
Is it? Is it now visible, ma'am?
Yes, ma'am.
Yeah. Good morning. Um, this is Julie Sharine, working as assistant professor in the Department of Computer Science and Engineering, St. Joseph's College of Engineering, from Chennai, Tamil Nadu, India. So today's topic, what we are going to see is basic electronics and home electrical installation, safety and skills. So this is the topic and the agenda. What we are going to see for today's session is introduction, followed with what is the basic difference on electricals and electronics and what is basic electronics. For dealing with electronics, what are the basic electronic components we are dealing with? Then, as the second topic goes with electrical installations, so we will be dealing with what are electrical installations, then home electrical installations, and what are the safety and skills that we are going to focus on these home electrical installations. So first, when we talk about what is electronics is, so here nowadays daily we are in a world where we are much connected with the electronic devices. So electronic devices, for example, we can say the handy ones what we really daily we have is the mobiles, the computers are very good example right now we have. So when we talk about what is electronics is, it is the branch of science and engineering that deals with the study, design and application of devices and systems that uses the flow of electrons. And currently we see this as the electric current to perform various functions. The various functions what we say are nothing but the control systems, the communication, the computation and the automation. And when we talk about the electronics, the basics of electronics is what or how the electronics is related with. The electronics is nothing but it is based on the movement of electrons, and these electrons are nothing but the negatively charged particles. So the movement is called electric current, and this has the power. This is the going to give the power to the electronic devices. And as we say, we have control systems over this. What do we control here? We control the flow of electrons through circuits to make the things work very well. So circuits and the electronic basics make the devices to work in the best way. So what is a circuit? When we talk about what is exactly a circuit is, it is a complete path through which the electric current flows. It typically flows or it typically includes a source of power or wires and electronic components. So here when we talk about the components, this plays a major role in the entire electronic devices. So here we have the components like resistors, capacitors, diodes, switches, etc. So here now we are going to talk about in detail what are the electronic components we have. The electronic components what we have are the resistors, capacitors, diodes, light emitting diodes, transistor, inductors and linear integrated circuits. We would have seen in the motherboard, the computer, and where we have lot of colorful components in it. So those colorful components, when all been put up together in the circuit, we get the devices to be worked. So basically, when we deal with the electronic components, the resistor, capacitor, diode, light emitting diode, the transistor, inductor, and the linear integrated circuits. Each and every component has its own working, and when all these been put up together, you are able to work with the device. So when we talk about the components, here we have a resistor, and I have shown what is a diode, and next an example for LEDs. What is basically a resistor is? Resistor, it is an electronic component that resists or limits the flow of electric current in a circuit. It is used to control the voltage and current levels to protect the components, and it basically divides the voltages. And here in the first diagram, we have two representations. The first one is called as the resistor, and the resistor symbol is normally shown with this symbol. And this resistor, as itself, it is going to resist the flow of electric current. This limits the flow of current, and it is a very important component in the electronics. Then when we talk about what is a diode, it is nothing but it is a semiconductor device, and it is mainly made up of silicon, and it is acting as a one-way switch for current. So the first diagram in this picture, the first one represents what exactly a diode is, and the second one shows what exactly the symbol that is being used or shown. For drawing the circuit diagrams and all, we will be representing this with this symbol. Next comes the light emitting diode. The light emitting diode is nothing but it is again a semiconductor device that emits light when the current flows through it. So it has 2 points. One is called as anode and the other one is cathode. And since it is emitting the light, it is being shown with the upward symbol, that is it emits. So that is the meaning for this particular component. The next, a very important one that we have in the component, like what we have in the resistors, the transistors. Transistor is a semiconductor device, and again, what is the major use of the semiconductor devices? It is used to amplify or switch the electronic signals. So basically, we have two types of transistors. One is called as PNP transistor and the other one is called as NPN transistor. So in these two types of transistors, we can see the difference that the symbol one will be shown with an inward symbol, and in the NPN transistor, it will be shown with an outward symbol. So this is called as a transistor. Next is capacitor. Capacitor, this is the one which stores the electric charge with it, and when connected to power, and it releases when needed. An inductor, that is the next component. And here when we talk about the capacitor, as I said, it stores electric charges. It is being shown with the symbol of the one I have shown here. It is shown with this symbol. And then next one is inductor symbol. An inductor, it is another electronic component, and this stores energy in a magnetic field when electric current flows through it. So this, when we talk about the inductors, they are typically coil of wires connected together. So the coil of wires is what shown as a symbol for inductor. So when all these components are being used with the circuit board, we make an device. And last and the very important and nowadays what is being used is integrated circuits. That is, they are called as ICs. An integrated circuit is or otherwise called as a monolithic integrated circuit, and it is a set of electronic circuits on one small flat piece of semiconductor material that is normally a silicon. So most of the material in the one we are using with the semiconductor material is a silicon. So this is an example for an IC, and this is what we normally call or use as a symbol for integrated circuits. Next is, we have seen an example for a resistor. And when we talk about the resistor, we could see lot of colors that is being surrounded over the resistor. So we have to think what those colors are being used for and what is those things representing here. So when we take about the color codes, it is a set of colored bands printed on a body which tells us exactly what the resistance value is, what is the tolerances, and sometimes it's going to tell us what reliability or the temperature coefficient is. So here we have different bands. So bands are starting from 4 bands or 5 bands and then finally 6 bands. So when we consider this as a first example, the first digit is always shown with the digits from 0, 1 to 9, and the second digit is also again the values from 1 to 0 to 9, and for each color we have values. 0 represents the black color represents 0, second brown represents the value 1, likewise it goes till white and the color is 9. Next, what we have is the multiplier. What is the ohms value is? How it is multiplied with 10 to the power of 0, followed with 10 to the power of 1, 10 to the power of 2. Likewise, then it shows the level of tolerance. Level of tolerance is plus or minus the percentage, and finally the temperature coefficient. So when all these values are being put up together, we will be able to say what exactly the resistor value is. For example, the first one it is shown that it is 275 ohms, and when it is being shown with the 4 band, it is shown that it is 1200 kilo ohms. So likewise, the values of the color codes are very important for applying that in the design work. Next is, what are the different electronic quantities we are using? So when we talk about the basics of electronics, when we think about the basics of electronics, we need all these physical quantities. And these are the basic quantities used in electronics. The first is called as the current, which is represented with a simple I, and the unit is ampere, and the ampere symbol is U. And what is the measuring device we are using here? The measuring device is ampere meter. When we talk about voltage, voltage is U, and the symbol for volt is V. It's been measured with voltmeter. Then power with P, and watts is the symbol, and it is being measured with power meter. The resistance is given with R, and it is shown with the unit for the resistance is ohms, and its symbol is shown with this ohms, and it is measured with ohm meter. Next comes the capacitance. C. Its unit is farad, and the symbol is F. It is being shown with capacitance meter. Then comes inductance, where it is L, followed with the unit as Henry, H, and inductance meter. Frequency is represented as F with the symbol of Hertz, H is Z, and the unit is Hertz. And the frequency is measured with oscilloscope, as well as the period is also measured with oscilloscope. Here, the period, the time taken, that is being represented with the symbol of T, followed with the unit seconds, and the symbol is S. We have to note down here that the frequency and the time period both are being measured with the measuring device called oscilloscope. Next, a very important thing, the charge. It is being represented in the resistor, in the capacitor. So the symbol for that is Q, and its unit is coulombs. And the symbol for coulomb, it is represented with capital C, and it is being measured with charge meter. Next one, the conductance, that is being shown with the symbol G, with the unit of Siemens, and it is represented with S. And the conductivity meter is being shown here, is being given. A very important law that is to be learned or to be used in the basic electronics is the Ohm's law. The Ohm's law, it is being represented as voltage, which is equal to current into resistance, I into R. So V is voltage, I is the current, and R the.
Hello, ma'am. Hello. We cannot hear your voice. Hello. Hmm. Hello, ma'am. Hello. Your voice.
Is it audible now, ma'am?
Yes, ma'am.
Now?
Already. Yeah, already. Thank you.
Thank you. Thank you. Is the screen visible for everyone?
Yes, ma'am.
Okay. Our next important tool what we use is the needle nose, which is used to hold small wires and to connect what to be done properly. Then comes the wire strippers. So it is just to take about only the conductor part. Over that we have a sealing. So if in case this has to be taken out, the wire strippers will help you to take away the sheath over that, and only the conducting material can be taken out. For that purpose we are using this wire strippers. Then comes the diagonal cutters, which are used to cut the wires, which are especially the wires that are sticking at the bottom of the circuit board. So when it is connected at the bottom, we need to take this. So such condition, the diagonal cutters are used. Then comes the multimeter, a very important device, a tool that is being used in the electronics. So this helps us to test how well the equipment is or how well the wires are being connected. And it tells us whether there is flow of current, and also helps us to learn what is the level of current is. And this helps the solder for joining with the resistance and voltage. Then comes a very important, next important and a very important tool, that is the thing of the power supply. So without power supply, no circuit can work. For that, we use this power supply, and Dremel drill. This is used to only as a drilling small holes in the circuit boards. So circuit boards, it needs a small hole, means we have to use this Dremel drill. Then, before getting into the detail of the learning of the electronics, we should know what is the difference between the electricals and the electronics. So here, the electricals, it deals with the generation, transmission, and distribution of electrical power, whereas the electronics deals with the electrical signals. So this deals with the signals and this deals with the power. So you may get a question like, what is the difference between an electrical signal and a power? So power is the high voltage and high current, whereas this electrical signals are the low voltage and the low current. So here, when we see the different types of components that is being used with the electricals and with the electronics. In electricals, we have the motors, transformers, switches, and generators. Whereas in electronics, we have the resistors, capacitors, transistors, and the integrated circuits. And where are the major usage of the electricals is related with the power system, wiring, and next important thing is large machines. But the electronics, here we are dealing with the computers, the mobiles, televisions, and gadgets. So we can get into the major difference between the electronics and electricals are. This has to be learned, or we have to be very clear about what is the major difference. Next interesting topic is the home electrical installation. Home, this home electrical installation means we as an individual, we may not depend on the electrical wiring people or the other people. At times, we may be in need to work with the electrical installations. Certain installations like plugging, unplugging, and in order to use even the small plugs, the small, it is such a simple work, but then when it is not handled properly, we may end up with a lot of problems, like we may get a shock and it may be life threatening also. So, in such cases, the home electrical installation is very important as an individual person. So, here, what is electrical installation is? Nothing but it is a combination of electrical equipments installed to fulfill the purpose of what is exactly the specific purposes and having coordinated characteristics. So here we see in this diagram, we can see power transmission lines which are being connected then with energy meters, followed with MCBs, followed with the switchboards, and from the switchboards we are able to use the fan and the bulb. So this simple diagrams clearly explains us what is the source, how it is transmitted, and from the main board to the small switchboards what we have at homes, and how the transmission is done to the electrical devices what we use at home, and finally how it is able to deliver us the final thing is. The final thing is nothing but the regular usage of our fans or the bulbs or other electrical devices like refrigerators and other things on it. And what is the purpose of this safety installations, or what is the purpose for us to deal with the electrical installations at home? The basic thing is we need to distribute the electricity safely throughout the home to power all the home devices. So our home devices are lights, fans, TVs, refrigerators, and lot many things we use at home. So when all these things are to be done, even if we need our laptop to work for a long time, we need it to be charged. So in such cases, we need all the devices or to be charged means it needs a power. So the power for all home devices is being delivered only with the purpose of the installation of or the distribution of the electricity, and to protect the residents from electrical hazards through proper wiring and safety devices. So we all know that proper wiring is very very important in order to safeguard ourselves as well as to safeguard even the small electrical devices what we use at home. So, like electronic components, when we talk about the electrical components, we have few key components involved in the electrical components. The components are main distribution board, then the wires and the cables, then circuit breakers and fuses, switches and sockets, earthing system, and load and lighting. So when we see, like in electronics, we have seen lot many things like resistors, capacitors, inductors. Here, these components are going to play a major role in the distribution of electricity as well as the safety purposes for us as we humans need the basic safety measures when we deal with the electrical energy as it transfers a huge part. So the first one we call as the main distribution board. So this is an example for a distribution board. A distribution board, it is nothing but it is a panel board and it is an electrical panel. It is a component of an electrical system and it divides the main power supply into multiple circuits. So from the power station, that is from the electricity board, we get the power and the power is then distributed using the distribution board, and here the power supply is then broken down into multiple circuits, and this provides a protective devices like circuit breakers or fuses each circuit. Here we have some different types of uh, components. The first one is miniature circuit breakers. So what is mean by this miniature circuit breakers? An MCB or a miniature circuit breaker, it is an automatically operated electrical switch and it has been designed to protect an electrical circuit from damage caused by excessive current. At times, we cannot say that the flow of current is always going to be stable. At times, an overload may occur, or at times, a short circuit may also occur. So, when a power level is higher, I need this miniature circuit breaker, and it is helping us to protect the electrical circuits from further damage. So, it controls. That is why the MCBs are very important at homes. Next is residual current devices. This RCDs or the residual current devices, it is next and sensitive safety device that switches off electricity automatically if there is a fault. What is meant by fault here? Again, if there is any change or any deviation in the level of power supply, this will automatically switch off and this helps the other devices to to be kept in a safer way. So always the residual current devices are very important as it can switch off electricity automatically. So next is fuse. Fuses. This we would have seen everybody. Most of us would have seen the fuses and all at homes. And this fuse is again a safety device in electrical circuits, and they are designed to protect against overcurrents. So at times the fuse, we say that fuse is gone, meaning due to the electrical problem or due to overcurrent, it may shut down the entire things. And when the fuse wires is again properly connected, we may get the electricity again. Next is what are the electrical wiring for houses, and this is very important. We have different types of electrical wiring for houses. First is called as a flexible cable, and this is nothing but it comprises of some three or four types of wires, and all these wires are being wrapped up in a sheet. Then comes an armored cable. This is the second type of wiring, and here it is this type of electrical wiring. It is more flexible with a metallic sheathing over there, and this helps more protection to the conductors within the sheet. Why it is called as within the sheet? Because everything over that is being covered with the metallic sheathing. So we call that as armored cable. Then comes the underground feeder cable, and these cables are designed for moist locations, and these can be buried into the ground directly. So we have uh, these underground feeder cables nowadays everywhere it is being uh, used, and particularly it has been focused with the moist locations. Next comes low voltage wires. They are nothing but the circuits that run at voltage less than 50 volts. So when the voltage level is less than 50 volts, we are able to use the low voltage wires. And ideally these are all called as low voltage cable wires. These items include landscape lighting, doorbells, thermostats, and sprinkler systems. Solar cables are the next important one, and the solar cables are nothing but they are designed to connect photovoltaic power supply system. So here, as we see, these cables are known for high mechanical strength. Since they have a high mechanical strength, they have the capacity to withstand extreme climatic conditions. And since these cables can operate for a longer time span, that is for nearly 20,000 hours, at a temperature as much as 120 degrees, we are saying that it lasts for at least 30 years. So, solar cables are very high potential, or mechanically they have a high strength, and they are able to withstand with the extreme climatic conditions. Next, when we talk about the safety installations, here we are talking about home safety installations. So when we think about the home safety installations, everywhere we could use the sockets. Sockets are the plug-ins where we can use our plugs or other electrical devices to be connected with the switchboard in order to get power supply for the device what we are using. So here they are generally safer. uh, we are we use 3-pin plugs, 2-pin plugs, universal sockets, and next interesting one, that is outdoor weatherproof sockets. So here we say that normally the 3-pin plugs are more safer than 2-pin plugs because they are used due to the grounding pin. And when the grounding pin is connected, this prevents electric shock. Also, the earth pin is properly connected. Next comes 2-pin plugs, and this is used with the caution and to ensure that the socket is designed for the plug. And if there is an adapter, we have to ensure that the adapter is properly rated and it is of good quality. And next what we have is universal sockets. They are they may not always be the safest option. At times we can use. We have to check the voltage and the amperage requirements of the devices to ensure whether it is compatible to use the new external device what I have. Next is outdoor or weatherproof sockets. These are nothing but they are used for wet and humid areas to prevent electrical hazards. So, these are used as a covering over the sockets in order to avoid the at times it may rain heavily and the board or the switchboard it might be outside our home, and when it is not properly protected or when it is not being closed up properly, it may end up in some electrical hazards. Next very important things what we have is the safety measures. Always we have to follow the compliance instructions for improved electrical safety. So it is our responsibility to check out the appliance instructions that is being given with the appliances what we get. So we have to read the instructions that's being given. Then when we see this as an example, that is, we have a socket and we can see multiple plugs connected to the socket. When it is being overloaded with too many plugs, it will end up with some hazardous conditions. So always our electrical safety is very important, and so we have to avoid using a lot many or too many plugs in a socket, and watch out for overloaded outlets to protect your home. So it's mandatory for us as an individual, since we are the masters of our home, we have to take care of the overloaded outlets to protect our home. Then these 10 points I say that very important for the safety and skillful measures for our home. We have to replace or repair the damaged electrical cords to keep our home safe. So if we find any electrical cords broken or the sheath is being it's been damaged, it's our responsibility to replace that with the new parts. Keep your used and unused cords tidy and secure to prevent damage. At times, when we see the end of the cords, it may be a poor quality one, and at times we could see a rust formed in the end of the plugs. So, the cords. So, it is our responsibility to take care of those devices. If it is found with any rust or anything, that has to be thrown away, and it is our responsibility to keep the cords, used and the unused cords, clean and keep it safe. And this is the next important: unplug all your unused appliances. So most of us nowadays we are staying with the mobile phones, and nowhere we are going without mobiles. So everywhere the plugging of the mobile charger is an important task nowadays. So, if in an emergency, if I'm going out of my from my home, I just unplug my mobile charger and I'll just put my and we may put our mobile with us and we may move out. We may not switch off the plug, the switch of the charger, and also with the laptop switches may not be closed properly, it may not be switched off properly. In such cases, it will end up with a large amount of damage to the devices what we are using. So it is always our advice to unplug the unused appliances to reduce all the tasks, potential risks. Next is keep electrical devices and outlets away from water to prevent shock. So any wet items cannot be kept with the electrical devices, because as a basic thing we know very well that when it is connected with water, it is going to pass heavy electricity and it will end up in a heavy damage. We as a human may get shock, so that has to be avoided. Next is give your appliances proper space for air circulation to avoid overheating. So, when we find that we may be sitting with the TV for hours nowadays, so When we sit with the TV, with the laptops, or with the mobiles, we can feel that those devices are getting overheated. When overheating is occurring, our device, what we are using, is getting into the problem. So we have to avoid overheating, that is the maximum usage of mobiles or the laptops or the TV or any electronic devices should be avoided, or the electrical appliances should be placed in a highly air circulated area. When it is being kept in such places, we are able to get that, we are able to keep our appliances in a safe and secure way. Next is ensure that all the exhaust fans are clean to prevent fire hazards. Exhaust fans probably we will be using in the kitchen, and we should keep the exhaust fans very clean, because when it is not clean and tidy, it may end up with some fire hazards. So, since it is mostly placed with the kitchen, it may end up with a lot of problems related with fire. Fire accidents may happen. So, it's our responsibility to keep the things in a safe and secure way. Next is check that you are using the correct wattage in all your fixtures and appliances. So we most of us will be using air conditioner, will be using refrigerators, and we have stabilizers also, because that is the one which is helping the appliances, because at times when it is overloaded, it may damage the appliances what we use. So we have to use the proper watts. What the part is, that has to be given with the proper way. Next is be aware of heaters and water heaters to prevent potential accidents. And everywhere we have heaters nowadays, in the bathrooms, and at times related with drinking waters also we are using the water heaters. So when we are using the water heaters, it is again a very important electrical appliance, and it may end up with lot many kinds of potential accidents. So, if we are using heaters, we may switch it on before some 10 or 15 minutes. And once we see that the switch, there will be two lights over there, colors. When the power is cut down, the light will be switched off, right? So, in such cases, we can use or switch off the heaters, and we can use that in the uh, bathrooms also. So it is our responsibility, our way of keeping the things safe and potential to keep us away from all kinds of potential accidents or fire hazards or any other kind of shocks or anything. So these are all the basic safety measures that has to be followed at homes by us for keeping ourselves in the safe and the secure place. Thank you.
Yeah, thank you, ma'am. And we have some question from participant already read in the Zoom chat.
One second. Yes, ma'am. Hope you all have gone through the presentation. Hope you would have understood what exactly the basic electronics is, and what exactly we are dealing with the electricals, and what are the important things we have. Yes.
Yeah, for first question, how can we ensure that individual with minimal technical background perform basic electrical installation safety and correctly at home?
Pardon, repeat.
The question already read in the Zoom chat also, ma'am.
Zoom's chat. Where is?
Yeah.
1 second. Yeah, yeah, yeah. I can see that. 1 second. How can we ensure that individuals with minimal technical background perform basic electrical? That's what I've shown you a few steps, right? Like what are the different kinds of materials we are choosing and what kind of product we are going to use. The product selection means the quality of the product what we are going to use is very important. And as a basic electrical installation, we are not going to use like we are not going to install or we are not going to connect the things and all. It is being will be supported by the electrical engineers, right? So we as normally use means the plugins and the plug offs, then uh, the appliances what we are using. The last 10 steps, as I said, that has to be done properly with us. And we cannot often find out like what is the level of the electricity, the power that is being shared. Those things and all, it's not easy for us to, as an individual, cannot measure or use. So the best and the safe thing what we can use is with the installation instructions that's been given by the appliances. Those guide steps has to be followed properly, and we have to use the instructions at home with the basic steps, with the basic safety measures what we have seen that could be done. To what extent should hands-on experience be prioritized over theoretical knowledge? Uh, Hands-on experience to be prioritized in the sense uh, when uh, when the engineering students, when they are getting into the initial level, when they are in the first years and all, they will be given with the guidance of how the basic things, like what is the neutral wire, what is the positive, what is the negative, and what is the earthing, grounding. Those things and all will be taught, right? Only such kinds of hands-on experience can be given, so that can be done. What are the most common safety mistakes in home electrical work? How can be prevented through proper education and awareness? Um, the most common safety mistakes, uh, the electrical work, when we consider those things, the installation only we can check. Installation as a normal person, we cannot just like that go with that. So we have to check how well it is being done only by cross checking with another electrical engineer. And since we all know that it has been basically connected with the electricity board, and if we find anything, only the basic thing what we can do is the devices, like as I told, the miniature breakers we have. So when all these are being properly installed, when we know the fuse is there, as a human, normally when we find that there is any difficulty in the things, we just go down with the main electricity board and we check what happened with the fuse. And fuse, normally in India, we are not allowed even to use the connect this fuse wires and all. Even if we get into such problems, we have been advised to get connected as with the electricity board only. Only those people will come and help us. So when we find something different, our best and the very good way to get out of the problem is we have to switch off everything and just come out with closing the main switch. So with that, we can keep ourselves, our appliances, as in the safer way. That's the best thing we can do. Any more questions?
Uh, I guess no one else asking again, ma'am.
Pardon?
I guess no one else asking again.
Okay.
Yeah, okay, before I close this event, for all participants, please open your camera. I will take a picture on the count of three for documentation. Okay, one, two, three. Okay, another one. One, two, three. Thank you for your kind cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Dr. Julie for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you so much, ma'am. Yeah, and
Uh,
goodbye.
Thank you. Thank you for the hope my session was supportive for you.
Yeah.
Yes.